This is the first question on the review set, and it asks about a recurrence relation for a closed formula. Now, this is not something where we have to generate terms of the sequence and then try to guess a recursive description. We can actually just check this algebraically. So, for example, and I do notice that this problem actually was supposed to be one that has multiple answers. I see it's only got one possible button you can check, but I think you'll find that more than one of these answers is correct. And I have no idea which one D2L is going to accept. But the idea here is that in each of the cases here, the formula on the right-hand side refers to a sub n minus 1, and of course on the left side it refers to a sub n. So we know the algebra formula for a sub n looks like that, and because of that formula we know that the algebra formula for a sub n minus 1 is just going to be 2 to the n minus 1 plus 3. In other words, it's the formula that we would get by plugging in n minus 1 in place of n in the formula. So we're taking this formula and changing n into n minus 1. The reason for doing that now is that I have an algebra expression for a n minus 1 and an algebra expression for a n. So each of these equations is really just an algebra equation, and we're asking if it's true. So for example, in the first one says a sub n equals 2 times a sub n minus 1 minus 3. So instead of a sub n, I can write 2 to the n plus 3. And the question is that algebraically equal to what I would get by putting on this side, instead of a sub n minus 1, the expression that a sub n minus 1 is equal to. So here's a sub n, here's a sub n minus 1, and all I've done is rewrite this equation using the closed formula for a sub n and the closed formula for a sub n minus 1. And so the question is this true algebraically? Don't forget, when you multiply powers of 2, we have a power of 2 times a power of 2. The exponents are going to add. And of course, we also have to distribute this multiplication through the addition here. And so on the right side, I'll have 2 to the n for the powers plus 6, that's 2 times 3, minus 3. And you can see that those two things are equal. The left side is equal to the right side. So these things are equal, so this would be a valid choice. I think you'll find that of the other ones, this one also is valid, and I honestly don't know which one of those D2L will check to be correct. Maybe either one. These two, algebraically, will not be correct if you do the same thing. This problem is just a simpler version of the same thing. In this case, we're not trying to check if we have an equation that's being satisfied. We're just trying to do the algebraic simplification. So again, if this is my formula for a sub n, that means that a sub m minus 1 is 2 to the m minus 1 plus 3. That's just using this formula, changing the n into m minus 1. And so this expression is very easy to algebraically simplify because I just rewrite it as 2 to the m minus 1 plus 3, since that's what a sub n minus 1 is equal to, 2 times that minus 5. So if you do the algebra again, powers of 2, if you multiply 2 powers of 2, the exponents add, so we have 2 to the m. We'll have plus 6 minus 5, and so it's easy to see that the right answer is, where is it? That one. It's the same thing.